Welcome to the presentation for the final project in data programming course in Big Data Analytics program. We are Nikita, Clancy and Shane, and currently we are studying at Georgian College, Bari, and for the last few days we have been busy designing and implementing an analytics system for an imaginary movie theater company. Let us pretend for a moment that the idea came from the market research company. This company was specializing in entertainment, and with current lack of new movies, this company was in search of a system that could analyze movies of the past and visualize their information in a meaningful manner. The one that allow their clients to pick movies for reruns. The company, of course, wanted to build and maintain a website for the system, so that their clients, various smaller movie theaters struggling during the lockdown, could access the data remotely. The moment we came to know about the project, we accepted it because we found the task very interesting. We have handled different positions before, and for this project we assigned to ourselves those that would allow us to give most to the project. I am heading the development process and visualization. Shane is handling data and business analytics, and Clancy is managing the project. Our team has designed a website which denotes the data of the movies, using publicly available data of 1,000 top-rated movies of the Internet Movie Database. In case anyone doesn't know, IMDb is a web platform for movie trivia and reviews, famous for their relentless critics. The source data was gathered 2 months ago and packed in a CSV file, but would it be a real system, of course, the data would be aggregated regularly from a variety of sources, not only IMDb. However, for the demonstration purposes, this should be enough. This dataset was taken from Kaggle, and it was already neatly cleaned and devoid of missing values, so we could use it immediately. The only changes we needed to do to it were mostly cosmetic, tying up the loose values, like score and domestic growth sometimes being in different notation for no reason, for example, thousands or millions for growth and integer and float values for score. After preparing the dataset, it was time for us to peer into it and devise the business logic, to understand which questions we could answer for our client. Of course, our client would pick movies by their rating and growth, but we needed to have understandable information, not only about the movies in general, but the specific ones as well. After a little brainstorm, we finalized the questions that would work on and display on the website. What genre was the most popular? What genre gets the highest score and growth? How dependent is the movie's growth to its score? How often would movies of certain years reach top 1000? Is there a way to pick a single score and stick with it? Are movies of the latest years more successful than movies in the past? And finally, how good a certain movie performed compared to other movies in the same year? Now, when our goals were clear, it was time to get to work. First of all, the dataset needed to be transformed into a database so that all of the business logic could be performed on the fly, directly operating on the data. Shane took on that part, and it proved to be quite a challenge to not only create and host a database, but also create a REST API with all the various endpoints which would connect to the front-end functionality of our system. Take it away, Shane.
Thank you, Nikita, for introducing me. Good evening, Professor, and whoever is watching this. I'll be taking over and handling the backend and running you through all the processes and the functions that I created. We can start off by looking at our repository, and then we have our entire functions listed here. But to give you a quick rundown of how we delivered our API, as the API is the choice format that we decided to go to deploy our data, and for that we decided to go completely cloud-based and used AWS as our preferred data SaaS platform, and we did that with a combination of adding RDS and Lambda. RDS we use to handle the database. As you can see here, we have set up a simple project with a MySQL database, and this is configured so that we have a maximum uptime and do not have to worry about our data storage needs. And our functions are written in the AWS Lambda. This we deployed them using Python as per our requirements, and created a REST API for each of our endpoints, and they were all deployed with the help of a strictly Python and a few dependencies, which are all listed. But for the most part, we use Python, and along with Flask and PyMySQL, and the simple JSON library. These functions are listed according to their functionality and can be taken a look at individually, but to run you through a quick summary, AWS Lambda handles everything as a event and a context. The event gathers all our data. What we do is get the data, do all the manipulation. In this case, we're going to be taking a string and returning the correct movie ID. Do a quick search and return our relevant data to our API endpoint. These endpoints are various and listed in the as we can see here. Along with CloudWatch, we have set up so that we can monitor our functions, and helped us a lot in our debugging needs at many times. And all our API deploys the data straight to our front end through get and post methods. They have created just an easier flow of integrating them with the front end that was created, and are all functioning just so that it just delivers the data, and we manipulate it completely on the server side, and returns the necessary information, which reduces the load time for the front end as well. As you can see, this is a quick overview of our schema that we have stored all our data. And yeah, and that concludes my presentation on the backend. For more information, please check out the repository, and we have listed all our functions along with an explanation. And thank you for watching my part. Hope you have a great day. And back to you, Nikita.
Thank you, Shane. Moving on to the front end, it was my part of the job, and the stack of technologies to pick came to me rather naturally. Since our imaginary client wished to see the Google charts utilized in the project, it could go two ways, either implementing them as an iframe or using the wrapper library for React. I chose the latter, and for a good reason. React.js comes with a navigation router and an easy lifecycle that allow for quick development of easily expandable systems. If the clients want more, React can always give them more. Then it was about the routing setup. The website would have 4 views, each corresponding to different functionality. The home view would get us the general information about the movies we have in our database. It would contain 6 charts, each responding to one of the business questions we pose. How often would movies of certain years reach top 1000? As you can see, not often, but the closer we get to current year, the more of high-scoring movies there are. What genre was the most popular? Here you can see the genres and their share. Is there a way to pick single score and stick with it? Here we go, average growth for each score. How dependent is the movie's growth to its score? We need to know if we can trust our data, and this big chart shows us that we can. What genre, the highest score and gross. Right on the bottom, bigger bubble means a bigger amount of the movies of that genre, and the locations on the charts relate to score and gross. Finally, are movies of the latest years more successful than movies in the past? Of course, surprising no one, they are not. In fact, it seems that the only reason there are more high-scoring modern movies is only because there are more movies in general, and their overall quality actually dropped significantly from the 60s. The second view is the search view. When the user wants to know information about one movie or another, the easiest way for them to find those would be to search for the title. Our system then picks the movies out of the database, looking for ones which titles are remotely close to what the user typed in. It then displays those movies in an alphabetical order, along with their description and posters. The third view is the listing view, which shows all the movies sorted by their rating. The most rated and highly praised movies show up at the top of the list, while the least rated are in the back. Using the pagination on the top and at the bottom of the page, the user can navigate through the list. Once the user has finally found what they wanted, they can go into the fourth view, the movie view. Don't mind the ugly poster. The image quality was very bad and we didn't bother to replace posters of 1,000 movies one by one. What's important is that the user now can see the information about the movie. On the top of the page, we have the general information: who directed it, who starred in it, what genre it was, and what the movie is about. It also shows how well did it perform in the theaters before. Of course, these numbers tell the user nothing, unless they can compare it to something. Here is where our last question gets answered. By comparing this movie to other movies that came out in the same year, we can figure out whether this movie performance was great or subpar. In this case, we can see that, although the movie was praised by the critics, it didn't do so well in the theaters, getting less money than its competitors. In conclusion, I must say we did a pretty good job on covering the basic analysis and creating a tool for our imaginary clients to sell to the imaginary movie theaters throughout the world. This tool can be used in addition to their own analytics, or on its own, allowing quickly finding and assessing the information about the movie industry in general, as well as individual movies. The design of the user interface is also pretty basic at this point. Simply the navigation menu, the search bar, few charts wrapping the nesting components, and a little bit of CSS to make it look fine and dandy. Our expectations were met, and we are hoping that this prototype build can satisfy our proposed client. We concluded that it's functional, but it has a lot of room to improve. But this can be done on later stages of production and integration. On some user testing would pass, the feedback could be implemented to expand on an existing system, styling it and adding more functionality. This is the beauty of the technologies we use. Anytime there is need for more functionality, more information or more visuals, the system can be easily scaled to the required level without becoming a money drain for our clients. The hosting we use is also easily scalable thanks to Amazon, and its maintenance is way less encumbering compared to other platforms of the market. Working on this project provided all of us plenty of insight and experience that will sure come in handy in our future endeavors. Group 4 signing out. Thank you from Nikita, Shane, and Clancy for your attention, and take care.